All right, in this video, we're going to be talking about dilutions, where we are taking some stronger chemical. We're going to be adding that to some water to dilute that to creating a solution with the same chemical, but of less strength. So the best example I can give you is literally from this morning, and it's with my kids' orange juice. Right? We got a gallon of orange juice, which is pretty sweet, generally speaking. My kids don't have that much sugar. So what do? I take their sippy cup, I fill it half with water, and then I fill the other half with orange juice. What did I do? I just diluted it, right? So now they can drink this volume, but instead of drinking this much orange juice, they're now drinking this, which is half water, half orange juice. Still has good flavor. They have no idea, right? But it's half the amount of sugar. That is a way of diluting whatever I'm talking about. In this terms, it was the orange juice. So now we want to apply this to the water world side of things. We're going to apply it with a really easy example where we're talking just generically. Okay, so we're just going to say that I've got some chemical. In this case, we're just going to say that I've got 1 pound of a chemical, right? I'm going to add that to, in this case, I've got a drum full of some water. I'm going to add that to 9 pounds of water. And what am I going to create when I add these two together? I'm going to create what's called my solution, right? This is now what has been diluted, right? So what do we call this? The chemical that we're adding is what's called my solute, S-O-L-U-T-E. Whatever I'm adding it to in order to achieve this dilution is what I call my solvent. In this case, it's going to always be water for us, right? Water is considered a universal solvent. There are scenarios where we don't use water, but in this case, for water math, we're always going to be using water. Now, this solute is added to the solvent to create my solution. Now, if I added 1 pound of solute to 9 pounds of solvent, or a pound of chemical to 9 pounds of water, what's the weight of my solution? Well, it's just going to be the addition of those two. So now I have what is called what is a 10-pound solution. Okay, so now in this scenario, what do I want to calculate? I want to calculate the actual strength of this new solution that I just made. And the formula is very simple. The formula is going to be, we're always going to talk about this in terms of weight. It's going to be pounds of solute divided by pounds of solution, right? This assumes that whatever my solvent is doesn't have any of this in it already, right? In the case of my kids' OJ, the solute is the OJ, the solvent is water. When I added the two together, I created this new solution, which is essentially half sugar OJ for my kids. So what do we've got? Pounds of solute divided by pounds of solution times 100, and that's going to get me to the percent of whatever this chemical is in this new solution. So what do I have here? I have 1 pound of solute. My solution, remember, is the combination of the two. So I have 10 pounds of solution times 100. So what do I end up with? I end up with 10% strength of whatever this chemical is, like 10%. Now, this is sort of the generic version of it, very kind of simplified version of it. What we're going to see oftentimes, though, is we want to care about something specific, a specific chemical. In this case, let's talk about chlorine, right? A very common one, okay? In this same scenario, I added a pound of solution of solute into my solvent. This is still going to be water. However, this is now going to be 12.5% sodium hypochlorite, right? So remember, what does that 12.5% mean? It means that of this entire volume, only 12.5% of it is actually chlorine. And that's what I actually care about to do the disinfecting of whatever this is. Say, making a solution to add a little residual to a reservoir, right, sitting on the top of a hill. 12.5% sodium hypochlorite is what I added to water to create this new solution. Now, this new solution is still 10 pounds, right? That's the total weight. But what I want to know is what is the percentage of actual chlorine, not just the percentage of the chemical added, right? Like the previous example. So what do I need to know? Well, I need to know pounds of chlorine added, and I'm going to divide that by the pounds of the solution. So very similar to my last example, times 100. What I'm not directly given, though, is I'm not directly given pounds of chlorine. So what do I need to do? I need to calculate that. Now, what am I given? I know that I have 1 pound of solution. I'm going to multiply that by the strength in this case, that 12.5%. Remember, I need to divide by 100, and that's going to give me the actual weight of chlorine, right? The actual weight. So 12.5 divided by 100, that ends up giving me that 0.125. 1 times any number is going to be 0.125 pounds of chlorine, right? This is what I actually care about, that 0.125 pounds. So now in my dilution here, I've got 0.125 pounds of chlorine divided by the pounds of my solution, which is still 10. And then I'm going to multiply that times 100. So what do I got? I got 0.125 divided by 10 times 100. And I get to a solution strength that is 1.25% chlorine. Right? Just over 1% chlorine. Let's make sure that makes sense, right? We got this number, 0.125. I always want you to do in these calculations, just do a quick, does that make sense, right? If I've got a solution that's 12.5% and I add it to a bunch of water, the concentration of chlorine in this new solution should be less, should be a lot less. Let's check, well, 1.25. Yeah, that's a lot less, right? Just over 1%, from 12% to 1%. Does that make sense? Yes.